Hello, my wonderful students. This is Foldable 2 of 6.3, simplifying before adding or subtracting. Alright, so let me zoom in on our first problem here. Alright, so the problem is with this one, we have the same index, which is good, but we have different radicands. Okay. Normally I'd be like, oh, we're done. But we can actually simplify these and then factor them out. So that's what we're going to do first. So we're going to go ahead and go do our factor tree because I know makes it easier. I know 12 is 4 times 3. And then 4 can be broken down as 2 times 2. And then 75 is 25 times 3. And 25 can be broken down as 5 times 5. Then I have negative 3, or 3, sorry, is already kind of broken down. It's already in its primes. So now we're going to go and rewrite these. So I'm going to go and pair up all the ones together first. So I'm going to go ahead and just write it on the radical. Well, I could just show it here first. So we have 2 and 2, 5 and 5, and then what's left over is our 3 and our 3. So when we write these in our radical, we're going to have the square root of 2 times 2 times 3, and we have our plus symbol. The square root of 5 times 5 times 3 minus the square root of our lonely 3 by itself. Alright, so now we have two numbers that we can actually combine. So we have the square root plus the square root minus the square root. And if we see these, the 2 times 2 is actually 2 squared. 5 times 5 is actually 5 squared. And we still have our 3s, our times our 3, times our 3, and then our 3 here. So if we notice, we have our 3s that are going to stay inside the radicands, and the 2 squared is going to come out. It's going to come out as 2. Square root 3 because it's still left over, plus 5 square root 3 minus square root 3. So now we have our wonderful coefficients. It's our 2, 5, and negative 1. So we're going to use distribution property. We have 2 plus 5 minus 1. And then we have our radical 3. So I'll explain what I'm doing right now too. I just wanted to go over the math first. So we're going to simplify this. We have 2 plus 5 is 7 minus 1 is 6. Radical 3. So this would be our answer. But now we're going to go ahead and actually explain what we did. So first thing we did is we factored out each radican. As we did here, we used factor trees to do it, to factor out the radican. Then we simplified to find perfect squares. That's what we did here. See, we simplified everything out to find our perfect squares. Once we did that, we go ahead and pull out. So we simplify our perfect squares Then here we did distribution. And then we simplify it again to get our 6 radical 3, or 6 square root 3.